So this is a redo of number 50 on the final review sheet, just to make sure that it's clear. So again, number 50, there was a mistake in this video right here. So I corrected on the answer sheet in Google Classroom, and now there's a little short video that I'm making at this point called 2A. So here we go. The question for number 50 was xenon tetrafluoride, XeF4. We're going to write a quick little dot diagram for that and identify its molecular geometry. So xenon has 8 valence electrons. Fluorine has 7 valence electrons. In this molecule, though, there are 4 fluorines, so we have to multiply by 4. So that gives us 28 valence electrons just for the fluorines, and then plus the 8 for the xenon gives us a total of 36 valence electrons. Draw your skeleton structure. In skeleton structures, you know that the least electronegative usually goes in the middle, and that's true here. So we'll go ahead and set it up like this with 4 bonds on it, 4 fluorines. It would be impossible for fluorine to go in the middle because fluorine can only have 1 bond ever. It only has 1 open spot in its outer shell since it has 7 electrons. It has room for 1 more. So that 1 more comes from the xenon. And fluorine is the most electronegative element on the periodic table. So since it's the most electronegative, it will never donate electrons to anything else. It always receives, and when it receives, it can only receive 1. So of the 36 valence electrons, since each line counts for 2 electrons, there are 4 lines looking at 8 electrons. So I'm going to take away the 8 electrons that we have in the picture already, which gives us then 28 valence electrons to put in our picture. So if I put 1, 2, 3, 4, 5, 6 valence electrons around that fluorine, that gives me 8 around it because there already were 2 given this line. Same thing here. So there is our picture of xenon tetrafluoride, but we still have a problem because I only have 24 loose dots, and I'm supposed to have 28 loose dots. So on the rules that I gave you regarding drawing dot diagrams, the conditions were if you have too many electrons, the extra ones go around the center atom. So we'll put them around the center atom. And what that does is create 6 domains. So the electron domain geometry of this molecule is octahedral, since there are 6 domains. And if you're wondering about that, think about it this way. I just draw a little. If that was kind of a little pyramid on top, and then there'd be the mirror image of that would be on the bottom. So you'd have side 1, side 2, side 3, and then on the back side would be side 4. That'd be 4 sides. On the bottom, you'd have 4 also, which gives us 8 imaginary sides, and that's why it's called octahedral. But the electron geometry is octahedral, but the molecular geometry, when on a little sheet that I gave you describing the dot diagram, I think I'll link that sheet right here, a little geometry chart. So you'll notice that if there are, let this come up, we have 6 domains. So here they are, 6 domains. That means the electron geometry is octahedral like we said, but 4 of those domains are shared and 2 are unshared, so that makes this molecule square planar for the molecular geometry. So it should be square planar. So the molecular geometry is square planar. All right, so that's a correction on number 50. When I made the video on Friday afternoon, I looked at my answer key and just said draw the diagram. Well, I made a mistake on my answer key, so then this video is incorrect also, but now we have corrected it. So that was number 50. Xenon tetrafluoride would be a square planar molecular geometry.